Hello, everyone. Welcome to stuff about stuff that doesn't exist yet, but we're going to show you it anyway. I'm Damien Edwards. I work on the ASP.NET team.
David Fuller, an architect on the same team.
Same team, yes, yes. And we're going to talk about SignalR, which we have done quite a lot, but not recently. It's been a while. Other than we did a couple this year about this stuff, but it was so early that I don't recommend you watch them. They weren't very good. This one will be awesome, though. We've got some good demos today, which will all work. Yeah, because the code is fresh. The freshest, most organic code that we got from the developers this morning. So it's guaranteed to work. How many people here use SignalR? Wow! OK, how many people use ASP.NET Core and are sad that they don't have SignalR? All right, and how many people haven't moved to ASP.NET Core, but they want to know about what's happening in the future of SignalR? OK, which you'll only get if you move to ASP.NET Core. But that's fine. That's a separate discussion for a separate day. I want to say that everything we're going to show you is very, very new, extremely new. We are not releasing SignalR as part of ASP.NET Core 2. So we released preview 1 of ASP.NET Core 2 this week, and there'll be another preview and probably another one before we shut down and release somewhere around end of quarter 2, beginning of quarter 3 this year. And then we hope to have a preview of the new SignalR available at that time, and then we'll release it later this year. So as we'll see throughout this talk, there's quite a lot of changes. It is a complete rewrite, and we'll get into reasons why. But before we do that, it seems everyone here uses SignalR, so you all know this stuff. What was it? Well, or is it? People still using it, obviously. It's a great real-time web library, a stack for .NET. Plugs into ASP.NET. Has this thing called the Hubs API that you can push data to your clients from the server to browsers, to phones, to console apps, I guess. And we had clients for JavaScript. We had a C++ client, a Java client that wasn't very good, and a C# client.
Just be honest.
Is anyone using the Java client for SignalR?
Not.
Did anyone try using the Java client for SignalR and then gave up? No? Oh, wow. OK.
Send a pull request to fix it.
Jesus.
We're
going to rewrite it. And it supported multiple transports, right? So when we released SignalR, WebSockets was very fresh, very new, and so it didn't work everywhere. And so this idea of shimming or polyfilling in other real-time or push transports is a big deal. We were definitely not the first ones to do it. So obviously other libraries like Socket.io that pioneered this on Node.js. We support WebSockets and server-side events, and this horrible thing called Forever Frame and long polling. Ran on System Web or on Katana, right? So you could self-host it like Web API in your own process if you wanted to. And you integrated it into your ASP.NET apps via way of IIS and middleware and all that goodness that Katana brought along. And then we had this really cool feature, which was great. I've got one server, but what happens when I have more than one server and I need to scale out? Because scaling out stateless HTTP requests is pretty straightforward. We've been doing that for 20 years now. We know how to do that. But scaling out real-time persistent connections is still a fundamentally challenging sort of computer science problem. And so we have this turnkey support for a scale-out in SignalR with support for Redis and Azure Service Bus and even SQL Server as the scale-out mechanisms. And for those who are still using it, which is pretty much everyone in this room, we did a servicing release last week, I think. Yep. So you can go and grab 2.2.2. And I think we pretty much patched every layer. I think there was a fix in pretty much everything. And we fixed the highest impact customer issues that have been building up over the last couple of years, including in the clients and servers and the scale-out. So I encourage you to go and get that and report any new issues that you found, and we'll continue to support SignalR in that, guys, because we love it, and people use it, and it's great. And for those who don't remember what a hub looks like, that's what it looks like, but that's boring. That's old stuff. Let's talk about new stuff. New SignalR. So this is not a case of just taking SignalR and running it on core, although you can do that today with gymnastics.
Yes.
And has anyone tried doing that, running the old SignalR on ASP.NET Core? Nice. That's very brave people. Well done. It does kind of work if you get a build that works. Have you ever seen it work?
Yes.
OK. Right.
For like 5 seconds.
Okay. So we have to rewrite ASP.NET Core, SignalR, sorry, on top of ASP.NET Core. There's a whole bunch of new primitives, right? So we have a new HTTP context, which is very different from the old HTTP context. We have a new middleware pipeline, which is a little similar to the old middleware pipeline, but different. We have a dependency injection system now that's built in, so there's no more global host like we had to do in SignalR before, which is separate from the web API host, which is separate from the MVC DI, which is separate from everything else. We just have it built into the system now, so we want to take advantage of that. We have new logging systems, new configuration systems. We want to do that stuff as well. And of course, we need to run it on .NET Core via .NET Standard instead of just being, hey, it runs on system on .NET Framework, right? So there's stuff missing, and we have to, or there's might be code that we have to change. I guess is the short way of saying that. The bigger thing is that in building 2 major versions of SignalR over 4 years, and then having large teams at Microsoft deploy it in the real world to build great experiences, and then having customers use it in Azure and in their own environments to build great experiences, we learned a lot. We learned what weren't so good ideas in the framework in the first place, and things that just caused us issues. Now, there might be things that were very difficult for us to debug, or things that were just very difficult to get right, or things that created false senses of something. Reliability in customers, which really you shouldn't be trying to spackfill over things that shouldn't be spackfilled over. And so we'll go through some of these things in this talk. But we really want to make sure the new SignalR is built in such a way that is reliable in the way that you would expect when you use the APIs, and is much easier for us to debug and maintain at large scale. Okay? One of the biggest questions we would get is, I'm building this app, it's going to have 1 million customers, and it does this type of stuff. Can I use scale out for that? And we were like, well, really when you get to that type of scale, you have to do things very custom for your app load. And so we wanted to make sure that the new SignalR took that into consideration so it was easy to do. We also want to lay foundations for aspirations we have beyond 2.0. So right now, ASP.NET Core is still very much HTTP, right? You have an HTTP server, you have an HTTP middleware pipeline, and then after that, you run code. But we know in the world of microservices and new payload, new workload types, as .NET Core is taking .NET to new places, onto new types of devices, and into the cloud and into containers, we want to make sure that we can do more than just HTTP. We need to set the future for server-based .NET in general, using all the great stuff that we like about ASP.NET Core, using the DI, using the hosting patterns, using configuration and options and composable middleware and startup classes and all the great stuff that we've gotten used to, but just beyond HTTP. Okay? And so we want SignalR to lay those foundations for that next sort section of work. So that includes random protocols, MQTT, even TCP. You want to start up a socket server, and you want something better than just, here's some bytes, have fun. It'd be nice to have a programming model on top of that. Okay? And so we'll talk a little bit about that as well. It also opens up sort of the SignalR that you know and love to be able to be used in different ways with more clients, with more protocols. And we'll see some of that as well. All right, the first big one. We've removed the dependency on jQuery in the JavaScript client.
Yay.
Actually, it's more fair to say that we just opened file new JavaScript file, or TypeScript file, actually, and just didn't import jQuery. So, it was a fairly safe assumption 5 or 6 years ago when we first did the SignalR client. Pretty much everyone used jQuery in every new application. Still MVC does, because we use it for client validation, but we want to fix that as well. But now, people want less dependencies, and that's perfectly fine. And people are generally using larger, fully featured JavaScript frameworks, Angular, Aurelia, React, Vue.js, Knockout, whatever it might be. And so they don't want to pull in stuff that they're not actually using if they don't have to. Yeah, this was fairly highly requested. A lot of people got angry with us when we didn't do this. There were some workarounds from the community. You could plug in a shim that was kind of JQ Lite type stuff to get most of it working, but we never were able to take on that body of work while we were working on ASP.NET Core. It also opens up the client to working in more places. Now that you're not relying on jQuery, which is reliant on a lot of stuff in the browser, you can run the SignalR JavaScript client in a web worker or on a Node.js server, which is kind of cool. So lets it run in more places. What else? No more single connection for all hubs. So in SignalR today, generally all of your hub traffic, if you have more than one hub in your application, goes over one connection by default. You just connect to kind of the default SignalR endpoint / hubs, and all the stuff goes over the wire to know what hub any particular message is going to. And that complicated a lot of stuff. It meant that when we were establishing that connection, the client had to tell the server what hubs it was interested in. We had to have this payload of data. I don't know if you've ever looked at the data that goes over a SignalR connection. I'm assuming you have. And if you look at the connection phase where you first connect, there's a whole bunch of crap that goes on. There's like 4 requests and JSON payloads and all types of rubbish. And it's like, I just want to connect with a WebSocket and get data. Why is this so hard? Great question. We're trying to make that much easier in the new one. And so by removing and changing some of these things, we can simplify a lot of how SignalR works, which is good. It also made the non-default URL setup trickier. If you didn't want to listen on my application /SignalR or /hubs, I think it was, then changing it was a little unintuitive. And the default JavaScript client didn't work with it well, and like it just wasn't a really great experience. So we erred so much to the side of, let's just make it incredibly simple by default, that as soon as you wanted to do something different, it was actually just much harder to do it than it would have been in the first place. So hopefully we've learned from that, and you'll see some of the changes we've made as we move forward. Now that we're built on top of the same subsystems of ASP.NET Core as everything else, we can just use routing. And so now you'll set up your hubs using the existing ASP.NET Core routing system, just like MVC does, and just like if you're doing route to middleware for really, 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 really tiny little HTTP services, you can do that as well. So now it looks a little bit like that. And with that, I will switch over to David, and he will
demo super basic SignalR application. So what I have here is a file new ASP.NET Core 2.0 project. So I'm going to edit the CS proj so you can see that it's no magic. Can everyone see the font size? Is it good? In the very back, can you see everything? Yes.
Bigger?
Bigger.
Bigger. I see this.
What?
I see this. I see this.
No, I can't fit. I got to scroll. All right.
Very full screen.
So I have ASP.NET Core All, which is the Uber package, and I have SignalR, which is not in that package yet because
we should call it Uber. Uber. No, we probably can't call it that.
No, we get sued. OK, so I have a SignalR 1.0 preview 2, and it's a build from the nightly build that happened on our CI feed. So I'll come to the configure services, and I'll call services.add_SignalR. Oh, not that. Add SignalR. That adds the SignalR services required for it to function. I'll go to the middleware, remove app.run, and call app.useSignalR.
Pretty similar so far.
Yeah.
We've just got the DI now.
So like MVC, you call use MVC, you call use SignalR. Very similar API setup. So now, like Damien said, I have to map individual hubs to routes. So I get the route builder in here, and I call routes.mapHub. And I'll map chat, because chat is the only app that matters for SignalR.
We have better.
We all wrote.
We have better examples in chat later on.
They're different versions of chat. They're just different. Like,
OK.
All right. So I just created a class called chat.
Oh, this is an expensive
and visual.
class.
OK, good, perfect. Oh, it worked first time. Oh. This morning, this thing crashed. Like, it didn't crash. I'm kidding. Crashed like 4 times.
VS preview.
It's a preview.
.NET Core 2 preview.
It says preview right here.
SignalR nightly build.
It's OK to crash in preview.
Live on stage in front of 1,000 people.
All right.
Live coding.
No pressure.
No nervous at all.
Create a method called send, returns task. I'll return clients.all.invoke.
So this looks the same. Like this is a method the client will call, just like in old.
Right.
Right? No difference so far.
So the biggest difference so far is that this isn't dynamic anymore. We have moved it from dynamic because it was kind of wonky. You can get it back by doing hub of dynamic. We want to encourage you to avoid this because you couldn't get any API IntelliSense or help anymore.
Yeah, I mean, dynamic is magic.
So it works, but
you shouldn't start with dynamic.
For now, we'll go back to the.
We also still support the strongly typed client as well. So you can do
hub of T, where
client.
T is your specific interface for the client-side code, and get IntelliSense for all the methods.
Yep.
But for now, I'm going to do the strongly typed, weakly typed model, where it has invoke async, but it's actually a string you're passing in. It's wonderful.
Cool.
All right. Let's see if this builds. I have like 3 class files. This is getting fixed soon.
We're making that faster.
Yeah.
Yes.
All right. So back in startup, I'll have to call app.useFileServer, so I can serve my static file index. And I have the SignalR client JavaScript file, and I'll show you a preview. This is all compiled with TypeScript, so it uses async await all the branch.
So we wrote the client with TypeScript this time, and it's modular.
It's modular.
We planned to make it so that you could
import the TSD file.
Import the bit you want into your TypeScript file, and da 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 da. So it's a modern JavaScript library.
Very wonderful.
Right?
Yeah, I think.
Nice.
I think so. I think it's modern.
Did we use async await?
We did. Look at this.
Oh,
It has the
awesome.
awaiter here.
Very
All
nice.
kinds of cool stuff. So our client is on npm, but I couldn't figure out how to get npm to work very well, so I copied it into the folder. It's super hard, right? Because you get the npm, you get the script, and then you have to run like gulp or webpack to copy it into different folders. So I was like,
We should bring back webresource.axd.
that
and
was
just ship SignalR.
simpler though.
That worked.
All right, so let's code up some fancy chat UI. So I'll do input type equals text. ID is message.
Hopefully we haven't lost anyone yet. This is like the standard SignalR demo, but we're doing it with the new SignalR, and we're just highlighting what's changed so far.
How fancy it
in
is.
the very basic thing, right? OK.
Send value equals send. And then I need a message list. Let's do a fancy
You know, add some
UI.
bootstrap, make it pretty.
No,
Okay.
never.
What?
All right, so
Sprinkle a little bootstrap on it.
no, it would definitely crash if I did that.
Okay.
All right, so there's no jQuery, which makes things super hard.
But that's a good thing, as we all discussed already.
So this
right?
is your
No
fault.
jQuery
This is your fault. But I have to type document.getElementById.
I love watching David type JavaScript code in the browser.
I think this is right. Signal.hub connection. We don't have proxies yet. It is coming at some point before we ship.
Yeah, so remember, SignalR generates you a JavaScript file on the fly.
You import /js.
Gives you, like, we haven't built that part yet, but it's coming. We will have that part before we preview and ship it on NuGet.
So beware, the API is kind of rough. OK, so chat hub is what I want, not char, chat hub. Connection.I'll subscribe to an event handler. Say whenever someone calls send. And I'll use some fancy syntax. Oh.
Ooh.
Ooh. Has anyone done this yet? It's like ES6. All right.
C# everywhere.
I think Microsoft tried to. I don't even know who did that actually.
It's a one happy community.
Yeah. Create an LI. This would have been done by now in jQuery, but I'll just show you that we don't use jQuery. So document.
Actually, by now I would have gone to the jQuery doc site and I'd be going, hang on.
What's the
they
syntax?
deprecated that in 1.10. That's right. No. Oh, now it's on, or whatever it is.
Yeah. Append child. This is so verbose. OK.
Beautiful. Beautiful.
Wonderful. OK, let's hook up an event handler in the hardest way possible. Let's get the send button and add event listeners. So many words.
Look at that. Hang on. Look at that statement completion suggestion. How is that helpful? Like,
Just in case.
there's the one I want. Like, oh, goodness.
Right.
Go web.
This is going to be really good, this demo. I mean, after all this typing.
I applaud the fact that you purposely didn't bring in jQuery just to prove that we don't need jQuery, even though it would have made your life much easier. And we could have shown more demos if you'd used jQuery, because we would have been done by now.
My fingers are like super sore.
Your fingers are bleeding, I think.
Yeah. Connection info. Oh. All right, send. I think this is not case sensitive, but I don't trust it, so. All right, and now one more thing. I'll start the connection. So connection.con. Start, and then we'll do some super fancy non-async.
Ooh, because that was all
Anonymous
we used the
lambdas.
jQuery promises back then,
Yep.
right? So now it's all just pure browser promises.
Pure torture.
Pure torture.
Console.log. Any mistakes so far? There's no mistakes here.
We'll find out, I guess.
Let's take bets.
33. Connection.invoke. There you go. Well done.
I feel like I missed something. I feel this is wrong. Let's
Run
do
it. Run it.
Let's do it.
Run it. Run it. Run it. That's good.
Bum, 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 bum,
That's
bum,
good.
bum. Let's look at the console.
No errors.
Bum, bum,
Oh, there's an
bum,
error.
bum, bum, bum. Ah, I missed the favicon. Oh, well, it's fine.
Ah, lovely. So there we go.
There it goes. All right.
So what we've seen is that the new SignalR is about Takes twice as long to do the same demo as we did in the old SignalR.
Yep. But is it pure?
But it's pure.
It's pure.
Pure organic SignalR goodness.
To prove that it works across
With no jQuery.
No jQuery?
Of course, use jQuery if it makes it easy, but we don't need it anymore.
Oh my god, the mouse is stuck. Let me kill this thing. I'm in a VM in a VM.
Can you just Control+ in the browser instead?
Oh my gosh. Control+ in the browser?
Like zoom in.
Oh, zoom in.
Yeah, there you go.
Oh, no one can see this.
There we go.
No. Control+.
There you go.
Hello, sir. 3, 2 O's. Yeah.
Lovely, lovely.
Hi, dude.
So the next 39 minutes is we're just going to watch. Who needs AI when you have an architect
What?
who can answer his own conversation? All right. Can we show some other stuff rather than you just talking?
So that works.
OK. So what transport did that use?
WebSockets.
Use WebSockets.
Yeah.
So one of the things that we did in SignalR that you're all using today is we actually designed it around long polling from the very, very beginning. It actually started before David and I were working together. We had an office about 3 doors apart in the ASP.NET building, corner of one floor. And I wanted to do an example of doing asynchronous handlers in System Web using SQL Server notification, query notification things to build a chat app using long polling, because I couldn't find a good example of doing long polling with ASP.NET System Web. So I wrote that. I did that demo in 2011 or something at some conference somewhere, Mix or something. And then it turns out you saw that from 3 doors away while I was in Las Vegas giving it, and said, hey, I'm working on a similar thing, and WebSockets came out at the same time, and kind of SignalR was born. But the whole thing was designed around long polling, because we just assumed that most people would have long polling and that WebSockets was still sort of nascent, and most people wouldn't have it. That's not true anymore. Like, we just assume now that we want to design a system around the persistent connection to start with. And so this defaults to WebSockets. In fact, it is just WebSockets when you say connect. Can we look at the browser network window and see what's going on under the covers?
So I'll run the chat again to see what it does, and build will run. All right.
So while you're done, I'm going to set up a GoFundMe page so we can buy you a new laptop.
Never. Never. The touch bar, I don't want that. All right, so 85 again, showing network.
Can you zoom in on
I'll zoom in on WebSockets.
So there's 2 requests I see. I see a negotiate request, which is very similar to the old negotiate request.
Which returns like a string.
A client ID of some sort. Well, that's all it is, OK. And then the WebSocket connection itself. So I think in the current SignalR, I think you need 4. There's like a negotiate, a connect, a start, and then like a start has happened or something. And then you finally get events. So at least now we're down to 2. In fact, you don't even need negotiate. You can manually connect, and we'll show that a little bit later, and just have the single WebSocket connect straight away. What if I don't want to use WebSockets? What if I don't have WebSockets for whatever reason?
Too bad.
Too bad? OK. Cool. Moving on.
So I can come here and specify the transport manually. I can say SignalR. Is it lowercase r? That looks so weird.
It does look weird.
Transport type dot long polling. Where's my IntelliSense? All right. Now we have a pull request. And if I send data, it'll end. That won't work. Wait, what? OK, it worked. Did it like? Where's my like sender? You know what?
Zoom out. Oh, you got the message, right?
It totally worked, though.
It totally worked.
But how did it work?
We've gotten pretty deep into this already. It's like.
Oh, no, OK, there it is now. It was the Zoom.
Zoom.
The Zoom killed it or something.
There we go.
Poll, send. Super.
It's our old friend long polling.
Very inefficient.
So which transports are we going to support this time around?
Long polling, service end events, and WebSockets.
No forever frame?
Shot in the head.
Yay! Oh, that's very violent.
Can I say that? I don't even know if I can say that.
No forever frame. Forever frame was incredibly buggy, and it was only required for old versions of IE, so don't do that.
Does anyone support IE8 still?
IE8? Anyone? Have to support IE8? No?
OK.
Good. Because we don't anymore. Microsoft doesn't anymore. ASP.NET Core does not support IE8 anymore. Don't log bugs against us for IE8.
IE9?
IE9 maybe? 10, 11? Is there a 12? There's a 12, right?
Edge?
It's got 11.
I'm just kidding. Edge
Anyway.
works. Edge works fine.
Long polling works everywhere. So if you do have IE8, long polling will work.
All right.
But don't try and use Bootstrap because that won't work. All right, cool. That's everything?
Yeah.
That's good? All right. Let's look at some better demos. I mean, that was great. Don't get me wrong. But it was chat. And we've all seen chat 100 times.
Everything is chat.
Everything is, no, it's not. We've got better demos than chat. Better demos than chat. All right. So last time with hubs, we kind of just invented some stuff, but we didn't really think about it. So if you ever looked at the payload going over your hub sort of transport, it was just a bunch of JSON with some letters and some numbers and some your data. And people would say, hey, can I customize that? And we'd say, hey, no. Because we didn't write the system with any idea of being able to, it was very organic, just like this is organic and fresh from the farm.
Yes.
Not that type of organic. So we actually designed a protocol this time, and there's a spec for it. You can go and read the hub protocol spec, and I'm not going to click on that.
And it has things like should and must.
It is very spec.
It's very RFCS.
RFCS.
Yeah, it's very nice.
Clients must. Clients should.
Clients
meh, maybe.
Clients
I love that language. And we have multiple implementations. It's not just JSON. So we have JSON, obviously, but we also support protobuf. And we're talking about doing others. So WebSockets, one of the great things about assuming WebSockets by default is, hey, WebSocket supports binary. So why don't we do binary transports and get really nice, tight, packed message sizes, even for hubs, not just custom stuff. And so right now we have JSON and protobuf, and we're still debating whether we allow this to be super pluggable so that you could bring in your own implementation of the hub protocol using Bond or Captain Proto
or
Ballad
message pack or whatever you
message
like to
pack
do.
Or whatever you want, right? So read that if you're interested in how that works. All right, scale out before was magical, but quite problematic. And so it all relied on a global monotonic cursor. It was one number that had to be shared across the entire farm of servers that only ever went up. And everyone had to agree on the state of that number, which meant every time a message was sent anywhere on one of your servers, it had to take a lock and increment that number atomically, right? That's what a global monotonic cursor means. And it just goes up by one every time. So it worked really well for simple stuff, but it really limited the ability to scale out for different workloads. So that impacted the overall design of SignalR, and we baked in a lot of assumptions about how scale out should work into the core product, which meant when someone came to us and said, David, how do I do scale out for this app to this many users with this type of topology? We would say, don't use the stuff in the box, ignore all these things,
Make a new thing.
catch these exceptions and swallow that and handle this thing. Basically, there was really no good way of doing custom scale out. So we've rebuilt all this from the ground up. The new design is much more flexible. It's much less opinionated. We basically just give you a hook into when messages are being sent and to all the other type of state transfer things that go on. And then you get to write your custom scale-out provider. Now, of course, we're going to ship some. Don't fret. If you want the turnkey solution, we will have them. But you can now just take ours out and write one at the right layer, the same layer that we do. And it's this hub lifetime manager of T-Hub.
Yeah.
You can even do different scale-out per hub, which is kind of cool. So if you want like the Bieber hub for Bieber chat, so you have for his 40 billion fans to do it on one scale-out methodology, and then the Fowler hub,
which has more users.
More users.
Than Bieber.
40,000 fans. You can use different scale-out for that. We will ship a Redis and Service Bus implementation. Service Bus and Redis both work in Azure. Redis is great for on-prem. SQL, we're still determining whether we should do a SQL one or not.
Should we do it? Does anyone use the SQL?
Who's using the SQL scale-out today?
Because you have to.
Why? OK. OK.
That's the usual.
Standard answer.
Yeah,
they won't let us use anything else. Can I install Redis? No. OK. Can I have SQL? Sure. OK. Right. So that's why we wrote it in the first place. It was the lowest common denominator. But it's not. SQL's not a messaging system, so it was a little not great. OK. So we'll probably end up doing something again. It really wasn't that difficult to do it last time, except for that massive race condition that we had for 6 months.
You wrote the code.
I did write the code. That was my fault.
Don't let PMs write code.
I'm pretty sure you reviewed it 3 times. But we did find that bug eventually. OK. And part of that is that we can do different scale-out mod because of how flexible it is now. Even if you choose something like Redis, we can do different designs for Redis. So you can say, hey, every time a SignalR connection comes in, make a connection to Redis and just map them one-to-one so that every client has its own Redis connection. Incidentally, that's how Stack Overflow does their WebSocket scale out.
Which seems insane.
Which seems crazy.
But it works.
But it works. They have tens of thousands of Redis connections to their Redis server. Or you can do what we're going to show you now, which is a single Redis connection per server, which dynamically changes its subscriptions to Redis's pub subsystem based on the clients that are connected to the server at that time. Which means, the great thing about that is it means you have 20 servers and users spread across those servers. When someone sends a message, it only gets delivered to the servers where that message is, where the client for that message is on, right? You don't go to everyone, which is what the old SignalR does, which drastically limited its scale-out potential. So, the last thing, presence support. Presence was really difficult to implement in the old SignalR because we didn't really expose the underlying connection manager primitives that let you know who's connected to my server right now. How long have they been here? Have you not seen them for a couple of minutes? If we don't give you those primitives, it's very difficult for you to build a presence system that can detect when someone's laptop explodes and then their connection dies and then 2 minutes later you have to time them out, okay? We didn't really expose that to you. We had some hacks and Jabber used those kind of hacks.
That was good.
But we want to expose that properly this time.
Rest in peace.
So you track the presence of users in your app. Damien is online. He's connected with these 3 connections. And then when all the connections go away after a timeout period that's configurable, he disappears, and you're off to the races. Multi-connection. You can have more than one connection per user, obviously. You want to be able to support this in a farm, right? So you probably use some type of persistent store to know who's on what server at any time. And this is very much a work in progress, but we do have functioning code.
Functioning.
We also have a new Swift client.
Yeah.
Which we're going to show, right?
Anyone use Swift?
Anyone use Swift?
Anyone use Xamarin?
Everyone know what Swift is? Good. Swift is native Mac stuff, right? So let's have a demo of that. Let's see you showing that stuff.
Let's try to do some stuff now. OK. So I have a bigger chat sample, because all we have is chat.
All we have is chat. No, we have more chat.
In case you were worried, it's two-way chat and one-way chat. It's all just chat. OK, so let's start from the beginning. So I have a very ghetto server farm set up right here. So I'm going to build this application, make sure it builds. What I'm doing is, this code is just a little bit of hacky code to, whenever I launch this program, it'll create a different server with a different binding to a different port. And it does that by storing a file on disk with the number and incrementing the number whenever a server is added to the
Sounds super reliable.
It is.
All right. Is Azure built on this technology?
Maybe.
You just put the file in Azure Storage, and it would be perfectly fine.
It's just shared state.
That stuff is magic.
Super good. OK, so let's do this. Let's start Redis. Let me get Redis.
So have you started your servers yet?
No.
Are you starting Redis first?
Yes.
OK, so
starting Redis server.
Start
this.
OK. Is that Redis for Windows?
It is Redis for Windows.
Okay.
I got it via Chocolatey.
You could use the Windows subsystem for Linux and run Redis natively.
I could if I want my things to fill on stage.
OK, fair enough.
Start CLI, and I'm going to type in a command to watch everything go through Redis.
OK, so then we're going to see all the traffic in Redis.
Things happening.
Who uses Redis today for anything? Who's familiar? OK, wow.
Wow. On Windows.
Wow. All right, even some Redis for Windows.
Awesome.
People.
All right. Now let's boot up our server farm. Super massive scale.
This is how Azure works. Like you drag the slider.
When you drag sliders in Azure, there's some dude who runs a bunch.
1. 2. Oh, off by 1. Nope, back. Charging.
So I think I have 3 servers here, and you can tell because it says like server 0, 1, 2.
We should update this to be serverless.
Ooh.
Yeah. I don't know what that means. I just heard all the cool kids saying it.
Local server. It's probably a thing.
Probably a thing.
It's probably
anyway,
a thing
go
somewhere.
on.
All right, so 3 servers running, and now I need a client.
So we got 3 servers. They're all on different ports. We don't have load balancing, so just use your imagination.
5,000.
Right? They're all going to different addresses.
Let me load balance this manually.
This is called client-side load balancing.
First connection.
You tell your
though?
customers, try this address first. If it seems a bit slow, try this one. Right?
That's pretty good.
It's much cheaper than a big IP F5 device.
So we have 1 server, and now we're going to go to the second server.
So the first one's on 5,000.
Wait, is that right?
Second one's on 5,001. 5001 seems a little, you might need to load balance that one. Hold up, there it goes.
Somebody rage quit the server. OK, no, that's fine.
There you go. OK.
All right, here we go.
So 2.
The first number is the server ID, and the second number is the user for that server.
In the user names, you mean?
Yeah.
OK.
So user, this is good UI, by the way. I didn't do it, but I would have done the same thing. So
needs more Bootstrap.
I can't even complain.
Bootstrap solves all manner
Does
of
it, though?
evil.
Hold on. Is this responsive? Yeah, look at that. Good job. Good job, guys. Hey.
OK.
It doesn't even clear the text. It's super lazy.
Does enter work? Or do you have to click? Oh, it does work. They hooked up the forms
pretty good.
That's nice.
All right, so we just chat between ourselves.
So we've got 2 servers. We've got Redis, and everything you type is going over Redis. OK. Can we prove that? Can we see the messages going over Redis?
No.
Please?
Yes.
Pretty please?
OK, so let me try this again. Hey.
OK, so there's the message on Redis. OK.
Pause. There you go. Publish, chat, blah.
They can't see that. It's
you
just
can't see
like,
that?
it's nothing.
I can't even see it.
There you go. Cool.
So it published, I think, through Redis to the chat hub. And it sent the invocation. Method is send. Arguments is username, blah.
So it's sending it as JSON in this case. Okay.
Yep.
But we could send it to Redis
as binary. Yeah, whatever we want to.
Okay.
And here's the background updating of presence. So Redis tracks every server and every user that has members on that server. And when servers come and go, it'll update the registrations and then do the right thing, telling the hub itself.
OK, so the code that's tracking what user is on what server, is that running on the web servers or in Redis?
On each server.
OK, so it's on each server.
Yep.
When the SignalR connection comes in, it says, hey, this guy's new.
Yep.
Tell Redis, update a table or something, a thing.
Some Redis
And then everything knows.
Yeah.
And then periodically,
it polls every second to see who's on its server still.
Where does that happen?
That happens in each server.
Oh, OK.
Yeah.
Interesting. OK. So can you show us
so each server scavenges.
Someone going away?
Yes.
OK.
Someone going away or some. OK, let's try. Oh, my gosh. Did I click something?
Just put it in the background. It's fine.
It's 4 VSs. It's gonna like. OK. Let me kill this one. This is on server, I believe, server 0.
OK. So the user disappeared. I saw that. Did everyone see that? So when you close that browser, one of the users on the left-hand side disappeared. It disappeared from the list. Now, was that because that was a graceful close? Is that why? Like, did you get a notification on the server that that connection had gone away? Or was that a timeout?
So there's server 1, server 2. Server 1 had a guy. He went away. He broadcast via Redis that he went away, and then it got published to all consumers.
OK, so that was a graceful.
That was graceful.
OK, so what the client, she said, I'm going away now. When I close the browser, we detect that. We tell the server, and then we could propagate that. But what if it's not so graceful? What if it's disgraceful?
So imagine some dude was in the data center, and he fell on a wire, and the server just like disappeared.
Oh, no. Data center outage. There you go. Gone. So
Azure
lost a
outage,
server.
huge explosion. Usually goes away still.
OK. And that's based on timeouts?
Yes.
OK. So how complicated is that code?
Super complicated.
OK, good.
No. So this is a base class, and this isn't final.
This is a prototype, right?
It's a prototype.
Right.
So you derive from hub with presence, and you get events that user joined and user left, and you can do stuff with these kind of events. So you just handle these events on your hub, and the correct hub will get signaled on each server with the correct
nice.
Data.
And this is users rather than connections, right?
It is. Well, today I think it is connections.
OK.
Maybe.
Is it a map so I would know that?
Yes.
OK.
It's a map.
Cool. All right, makes sense. So has anyone tried to build this themselves in SignalR today? Was it an enjoyable experience doing it today?
sorry.
No. I mean, let me be honest. Doing this on any type of system isn't that enjoyable.
Super hard, yeah.
Networking is hard. And dealing with people driving into tunnels and losing their Wi-Fi and their laptops crashing, whatever it might be, is really, really difficult. But ultimately, we have the graceful disconnect scenario, and we have the timeout or disgraceful disconnect scenario, right? And so we hope to ship this in the box, right? One for Redis. Yep. This actually stores data in Redis. But we could also store, we could have a SQL version of it as well for the people who can't use Redis.
One on disk.
And you can get this presence API in all of your stuff. OK, cool. Is there a different client?
Let's do Swift.
Let's do Swift. Okay.
All right, so this guy's still open. He's still online.
The server running?
He's still happy.
OK.
I think I have server 2 still, just chilling out.
OK. No one connected to it?
No one.
Let's connect Swift to server 2. Or is that off script?
Oh, my God.
This is script.
Oh, my God. All right. So there's Xcode. Does anyone use Xcode? Has anyone tried Xcode? I got it last night for the first time. All right, so this is some stuff. And it runs an app. Let's see, the hub sample. I will hit F5. I think this is right.
I mean, it just looks like Signal.
I hard coded it, yeah.
It just looks like it's a hub connection.
It's a hub connection.
You set up some stuff, callbacks. It's just all Swifty instead of C#.
It'll use the idioms of the language, so you'll get a chat delegate for the callbacks instead of doing an on whatever.
So where's the actual SignalR client? Did you bring
Client
it
is
in?
here. You get a hub connection.
Did you bring it in? Is it a package? Like, how does it work in Swift?
It's actually so this is the actual client itself.
Oh, I
with
see.
the sample, so
But it'll be in a
it'll be in a whatever. I think it's like a.
They have a registry of some sort?
The pod thing. I don't know what it's called.
Okay.
Does anyone know what the Mac package manager is called? Is there a package manager for Swift?
CocoaPods,
right. We had one of those before.
Nice.
So I think the address is 5002 for the second server. So I'm going to do the hard code the address in here because that's what we all do in demos. And stop the previous client from running, apparently.
You still had it running?
Apparently, I had it running.
Awesome. That means you have a greater chance of
Boom!
success.
This is some awesome developer UI. Just like, watch this. Last night I was like, let me make it bigger. Oh, okay, that's fine, I guess. Hey.
Where's your code? Wait. Hey, that seems to work.
Ooh. And then he's like,
It's so compelling watching you
on,
talk to yourself across 2 operating systems.
I get super excited.
No one can read that text. It's so tiny.
Like, how do you zoom on a Mac?
Yeah, no one knows how to zoom on a Mac.
Just watch it.
You get closer to the screen.
Just look at it on this side.
Ha! See? OK.
Oh, it's close. It's close.
So we have scale out, we have presence, and we have a new client.
New
Swift
clients.
client. And we're going to deliver all of that, right?
Yep.
Excellent. Good stuff.
Yep. Mm-hmm.
I'm the PM. I don't have to do any of the coding. I just say, hey, we want all this stuff. Look,
It just says
the people like
the
it.
customers want X, and I'm like, okay.
All right, so we've shown you all the good stuff. Let me just briefly talk about the stuff that we had to change to make this stuff good. There are some things that'll go away. So there's no message buffering or reconnection. There's basically no reconnection anymore at all. SignalR connections are persistent. The WebSocket connects. If the socket breaks, your connection breaks. Okay? And then if you write the code to handle the error and connect again, which is obviously what you would do, then you don't get the messages that you were missing. All right? You want that, you have to build that into your system yourself, which frankly is a much better way of doing it because you know better how to do event replay in your system than we can generically. Okay? Having message replay built into the SignalR layer that wasn't really durable messaging caused us a whole bunch of problems from misconceptions, memory leaks, bugs, all types of things. So they will not be there anymore. Blah, 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 all the stuff I just said. So ultimately, you had to write that code anyway, because we would always give up, even when we were trying to reconnect. So you always had to write the reconnect code yourself. Long polling, incidentally, will still do this under the covers for you, because you have to do it with long polling because you don't have a persistent connection. You have one which comes back when you get a message and you have to connect again. So we will do a small amount of buffering for long polling on the server. No more hub state. Does anyone use the hub state feature?
Everyone's like, what's that?
Good.
Good.
It's gone.
Yes.
Never existed.
Telemetry. That's telemetry right there.
No more server ping pong. What does that mean? So we're going to require a server affinity for anything other than WebSockets. Okay, so if you're using service and events or long polling, you must make sure that that client is connected to the same server. All right, so sticky sessions, whatever you want to call it. This drastically simplifies a lot of how the back-end scale-out stuff works with SignalR. Now, if you're using WebSockets, you don't have to worry about it because WebSockets is a persistent connection. You'll go through your load balancer, it pins you to a server, and that's how it works. You don't have to worry about if that gets disconnected, you're going to go to the next server anyway. It's not a big deal, right? So, but when you're doing non-WebSockets, it's something you have to think about now. Point-to-point does require sticky sessions. And as I said, WebSockets just works. All right, let's get down to the low layer. So we've talked about the high layer, but there's a new underpinning technology under all this goodness that we are calling ASP.NET Core Sockets because we couldn't think of a better name.
It's a bad name, but
it kind of describes what it is, right? OK. So in the new world, this is kind of what the architecture looks like. So we have a host, which is in this case web host usually, but it can be any host. It's host agnostic. You have a series of transports. How does my data get to and from my client? WebSockets, other HTTP, et cetera, et cetera. I have something called an endpoint, which we're going to talk about now. And then I have hubs sitting on top of that. And then if I look at full-blown SignalR on top of this, you can see the same things, but now I have a bunch of HTTP transports, WebSockets, service and events, and long polling. I have some middleware that they sit on top of because they're running inside the ASP.NET Core web host pipeline. You know, it's the API in your program main in ASP.NET Core that boots up the HTTP server. And then next to that, I could have non-HTTP transports. I could have a TCP server, and I could have a TCP transport, and I could have different clients using totally different stacks connecting up to my same endpoints and thus my same hubs. So we're just really trying to expand the reach of SignalR and this messaging API, or this socket-based API, to as many different endpoints as you can think of. So what does this endpoints API look like? It's a generic API for programming server-based endpoints. You have a client, you have an endpoint on the server speaking some protocol, speaking some connection type, and the client connects to it. It replaces the old persistent connection API that we had in SignalR, which was still HTTP-based in the old days, and basically serves as a base for any type of connection. It abstracts away transports. You program as if you have what looks like a socket endpoint, but it could actually be connected via long polling, or it could be connected by
service and events.
Service and events, or something we can't even think of yet. It may not even be over HTTP.
Yep.
Could be
TCP,
UDP? Could it be UDP?
It could be UDP.
Could be UDP. Could be anything. And you just write code completely unaware of how people are connecting. It is completely host agnostic. So while everything we've shown you has been an ASP.NET Core on top of middleware, so it's all HTTP on top of Kestrel, you can plug this into whatever you like. You could plug it on top to a new host that can speak non-HTTP. I keep saying that, non-HTTP. I could do TCP. And then to make it simpler than just coding with bytes, because who wants to code with bytes, right? That's not much fun. We have this sort of sidecar thing, which is how do I read and write types, or T, to these endpoints with a pluggable infrastructure that makes it very, very simple. And we're calling those formatters. I don't know what they'll end up being called. It's a very similar concept of formatters in MVC and Web API. Like you return an object, and then based on the metadata of the current request, headers and things like that, some formatter gets invoked and then formats that object out to the client, and the same way coming in. It's a very similar concept, okay? But transport agnostic.
Yep.
Just deals with bytes. Chunks stuff out, or chunks stuff in, gives you the T that you asked for. That means that you can speak in JSON, in protobuf, in custom protocols, and in custom message formats, but your endpoint code doesn't change. It doesn't have to change. All it cares about is the order of execution, what type of message do I receive now, what type of message do I send now. So that's kind of what a very basic, terrible endpoint looks like. You derive from endpoint, you have a constructor, you use DI as always, then you override onConnected, and then you stay in the onConnected loop. That loop is alive as long as the connection is alive. So it's much more like socket programming, right? OnConnect happens, you get given a handle to the socket, and you just keep running. Once you return, the socket goes away. It's stateful, right? It's a much easier mental model to think about when doing this type of lower layer programming versus the hub model, which is much more like request response, MVC. Oh, a request came in for this hub invocation, new up a hub, call the method, take the result, send it back, the hub goes away. Okay, it's kind of ephemeral. This is very different. I grab a formatter out of my formatter resolver. I should probably use this, might make it easier here, okay? And then this is my custom messaging that I just created in this endpoint. I ask the formatter to read me a handshake message from the connection, okay? And that handshake message formatter will be read out of the formatter resolver. If I don't get a handshake message, that means the connection on the other side is speaking the wrong protocol. It's not speaking my language, okay? And so I throw an error. Otherwise, I go, right, I got my handshake, now send back the reply message. And then once I've done my handshake, I go into my while loop, and I just keep receiving whatever the next message type is on my custom protocol that I just invented. Okay? Pretty cool. We want to support binary, obviously. That's been a long-standing request for SignalR, and I'm very happy to say we have that. We have a demo for that, which I'll do in a minute. Oh, actually, you'll do it in a minute. So you can now send and receive binary data. In fact, the endpoint API just deals with binary data by default. And then there are nice ways of sending text over that as well. Hub connections can now speak in binary protocols. I already mentioned protobuf. You can accept byte arrays into your hub methods. I'm not sure it's a good idea yet, but we're going to support it.
Yeah.
And we'll see what people do with it. Frankly, I'm not sure you should upload an image over a hub method. Maybe it should be fine. It's a website, probably fine.
Yeah.
I don't know, we'll find out. And accepting a stream into a hub method, having a hub method that takes a stream so that you could upload a file into a hub method, perhaps. Well, no reason not to. Once you're speaking binary and you have a WebSocket, why not use it? But have the nice hub programming model in order to do it, okay? So these are all the things that become enabled by doing binary. Support for pure WebSockets clients. This is that whole one connection, I'm connected. I don't need to negotiate. I don't need a JavaScript client or some other client. I just have WebSockets. Let me connect. As long as I can get WebSockets, I can connect to the server. So They are the new model for SignalR by default, and then we kind of polyfill in all the other stuff after we've assumed it's WebSockets. All other transports handle their special requirements within their little part of the world, not SignalR as a whole being designed to handle long polling or server-sent events or whatever. It just assumes you have a nice persistent connection. They don't need much logic. You just open a socket and go. Very, very simple. And if you want to do hubs over a WebSocket, all you really need is a small library that knows the hub protocol and can dispatch. Say, I want to invoke this method on the server, here's my data, and I want to get stuff back from the server or have be invoked and turn that back into mapping to whatever method you have in the client. Right. And that's really the only logic that you need. And all the clients that we talked about, our intent is to have a smaller version of those clients that just do hubs, where you are just going to say, oh, well, here's the hub dispatch logic. Hook that up to your WebSocket or your TCP connection or whatever it is you're sending over, and then you can just talk hubs back and forth, okay? All right, so to show some of those things, I have a bonkers demo that will almost certainly fail.
Not chat?
Not chat.
One-way chat.
So I have this device, not one-way chat. So I have this thing. This is a board of some description. A Node MCU, it says on it. See this? Right, it's basically a Wi-Fi chip with a USB port on it, right? And the biggest part is the Wi-Fi chip, and I think this is the CPU, this one over here. I'm not really sure.
You're guessing.
It's very, very, very small. Okay, so I'm going to plug this into my USB port to give it power, and it will emulate a COM port so that I can speak to it using PuTTY. All right, everyone used PuTTY, right? Not everyone, but I'm assuming some people have used PuTTY. I had never used PuTTY before I did this demo.
Zoom in.
I will zoom in. So I'm going to load my SignalR defaults, and I'm going to open a session, and I'm going to hope very much that it works. So I'm going to hit. I got a prompt. That's a good start. It's like that scene in Jurassic Park when they reboot the server. It worked! The system's ready! OK. So then I have some notes because, like, oh my God, look at this stuff. Wi-Fi.sta.connect. Now that is going through my phone because I don't trust the Wi-Fi in here. So that probably worked. I don't know because there's no feedback from this board. We will find out in just a moment. And then I'm going to execute a Lua file. So this board speaks Lua. Okay, anyone? Lua is a scripting language. It's kind of dynamic.
It worked.
And it connected, so that's good. It's connected to Azure. So I have a site in Azure called Social Weather. Also beautiful UI. All the amazing design that we've done. All the work we put into these demos for you to make them look great. OK, and so I'm going to send a report. Let me pin this to the left, and I'll pin this one to the right. And I will zoom this in a bit. So I'm going to hit send report over here. And nothing happened.
You hit enter, I think.
I did.
Hit enter over there.
Oh, look, no, it just got delayed.
OK.
Azure was doing stuff.
Buffering.
Buffering, right? So I can change this. It is definitely not 72 degrees today. I don't know. What's the weather today?
50.
50. OK. Mr. I have a watch on my wrist that tells me the weather. It is almost definitely mostly cloudy, lots and lots of cloudy. I don't know what the zip code is here.
It's Friday.
What's the zip code? What's the zip code in Seattle?
924, I don't know. It's made it up.
Look at that. See? And now my Lua board knows that that is true. That temperature number looks a little strange. I have a feeling you're all messing with me. Didn't think this through, did
public.
Luckily, they can't. Well, they can, actually. You can type anything in here. So what's interesting, be nice. Be good.
That's the board.
All right.
Alderon.
So this is what the Lua script looks like. So this is the entirety of the code running on that board. Because it's a very small board, you can't run much code. So when I said do file and ran that Lua file, this is what it ran, OK? Creates a client, connects to the thing on the server, sets up a little, when a message comes in on the WebSocket, it prints stuff out, grabs stuff from the message, loops through the tokens, and basically parses this custom protocol that this client is speaking. However, the JavaScript code up on the browser, Alderon, that's funny. The JavaScript client up on the browser is speaking a different protocol. So I can actually send from this client as well. So if I come back over to here and I get my notes, I can send. So I can say not in there. I can do it over here. I can say ws::send
and I can say it's 32 degrees, pipe, I don't know what the 2 is, I don't know what the 0 is.
Is that Celsius?
No, it's in Fahrenheit. And then
cold.
new line, and then it is cold. And then if I do that, in theory, if I bring this one back up, and I bring that one up, and I hit enter, there's my 32 degrees that I just sent from the device here, through my USB COM port, up through my phone, up to Azure, back through the thing, back down into the browser here, right? Speaking different protocols, which is kind of cool. So how does that work? Well, the endpoint, which I have here somewhere, here it is. This project here, the endpoint has a bunch of formatters registered such that it can speak protobuf to a C# client. It can speak this crazy pipe-delimited text protocol that we invented for this demo, for this Lua board, because it's easy to write Lua that can speak that language. And it speaks JSON for the JavaScript. But the endpoint code is identical. And I just have to find it. There it is. So this code here doesn't know anything about what format it's writing. It simply says, get the format type from the metadata for the connection. So when the connection connected, it said, I speak foo, JSON, protobuf, crazy Lua script thing that we made up. And then it just says, read me one of these off the transport, OK? And then when it gets it, it turns around, reads it, sends it back out to everyone else. This code is the same for every client. All the code around formatting is in a different part of the system that I registered, which is kind of cool. All right,
Awesome.
So that's social weather.
That's pretty good.
So that's SignalR in places you've never seen it before, all right? Never seen it. And there's no reason you couldn't do a hub demo on this as well if you wrote the hub dispatcher for it. So we have one last demo,
All right.
Image Caster, which is going to show off another new feature, which is binary support.
It's our new startup. So
Is that a new startup?
what I have here is a web page. Let me run this application that uses the camera APIs in the browser to stream video. So in a second, when it runs, it'll turn my webcam on, and I'll be able to show you my face, but really close, so you feel uncomfortable.
Photobomb. What?
It'll build, it'll
Come
build,
on. Come on.
it'll build. Time is running out. Help me out.
Plenty of time. You got 3 whole minutes to finish this compilation. There we go.
All right. So server's running on 5,000. I'm going to boot up web browser to localhost 5,000, wait for it to compile the browser page. This is faster than 2.0, by the way. I promise. All right, here we go. All right, so I'll turn capture on so you can see it streaming.
Very slowly. It just looks like it's copying onto the other part of the page. That's not an impressive demo.
It's pretty cool.
OK. That's actually, is that doing anything interesting? What's it doing?
This took like a week.
I know it did, but like, what is it doing? Why is it so good?
You want more?
I want more.
So what it's doing is sending binary data from the camera itself. Oh, my computer's like on fire now. It's super inefficient.
So it's capturing live frames from the camera feed
from the canvas.
using the browser camera APIs.
Send it to the server side as raw binary.
As a JPEG.
As a PNG.
PNG.
A ping.
And then we're using server-side image magic.
Right, so this is server-side.
Image sharp, actually.
So yeah, so this is the server-side endpoint for the image. And it reads data off the transport itself. It gets the data into a giant message because it sends it over a chunk payload. It loads it via a library called Image Sharp.
Image Sharp, great open source.
.NET Core library.
.NET Core library. .NET Standard library.
It checks the format. So if the format is ASCII, it turns it into ASCII art.
Oh.
Which I'll surprise you with. Don't look at the code. Don't
forget that part. That's the end.
And it broadcasts to everyone.
OK.
OK, so now I will start this other client.
So we have another client. This is a console client. Look at that.
Let's show something else that's like.
Which is lagging just a little.
It's a tad bit. Look at that.
There you go. There you go. That's discernible.
I see an 8.
We may not have performance profile optimized this code yet.
I think it uses like a couple hundred.
But it works. And it was like, what, 30 lines of code in the endpoint or something?
Yeah, look at that.
Yeah. Incredibly simple. Wow, look at that CPU.
Who's doing that?
System interrupts.
I wonder what's happening.
Drivers. Awesome. All right. That's a pretty cool demo. I do like that demo.
My
so
beard.
that was showing binary and the endpoint API with Different clients. Again, this is about expanding the reach of clients, expanding the places that you can have real-time data going to from your SignalR applications. In this case, doing silly things like sending images, broadcasting them as ASCII art, which is kind of cool. All right, so the roadmap to finish off. The work is in progress right now. We are targeting a preview for around the time that we ship 2.0 of ASP.NET Core. So that when ASP.NET Core 2.0 comes out, you can get the SignalR Core preview. Okay, that's our current goal. That will happen around Q3, sometime in Q3 this year. We hope to have the TypeScript, JavaScript, and C# clients at that time, and then, or probably the Swift client as well.
Swift, yeah.
And then the C++ and Java clients would come closer towards release. You can follow along. All the code is open source, github.com/asp.net/SignalR. And if you want to try out, if you're brave and you want to actually use packages that contain this crazy stuff right now, you can get them from our CI dev feed on MyGet. Okay? Thank you very much, everyone. Please complete your evaluation forms.